All right, a little bit of graph review. What does the graph of sine look like? I want you to sketch the graph of sine over this interval. I'm going to start with, we're used to the cycle where sine begins at 0, then goes to its peak of 1 at pi over 2, back to the midline at pi, down to its lowest point of negative 1 at 3 pi over 2, and then finally back to 2 pi. So that is the normal cycle of graph that you want to be familiar with. If I go backward over to pi over 2, then I will see that pi over 2 is at negative 1. Now, I want you to highlight 0 to pi over 2. I'm going to actually use a highlighter. Let me make it smaller. How do I make it smaller? Smaller. So 0 to pi over 2, just that piece right there. Just highlight that. Now, perhaps you do, perhaps you don't remember the vertical line test. The vertical line test was to determine whether a function, or to determine whether a graph was a function. The horizontal line test is the idea of, and let me just draw a fun little parabola. Horizontal line test is failing because if I draw any horizontal line above that vertex, it will cross it more than one time. So that means its inverse is not a function. We are just beginning to create the inverse trig functions. We're just going to go so far with them, though. There are 6 trig functions, so there are 6 inverse trig functions. We need to look at what angle range will keep us from violating the horizontal line test, will keep us from crossing 2 points with any horizontal line. So part C is asking if you continue forward, highlighting the graph from pi over 2 to pi. And I'm going to change color on that. Will I pass the horizontal line test? And hopefully you realize the answer is no. Now, next, hold on, let me pick another. Oh, I am so ready to be done with everything via computer. Anyway, the next part of part C. If you go backward and continue highlighting the graph from negative pi over 2 to 0, it looks like I cut off my negative sign there. Will the highlighted portion pass the horizontal line test? So if I look at just this yellow piece with the green piece, just those two together, do you see that those two will pass the horizontal line test? And then I want you to make sure that you clarify to yourself the portion that passes the horizontal line test. Let me bring that down just a teensy bit. And then I'm going to overemphasize this piece right here. That is the part of sine that is used for the inverse of sine. If you've with your calculators used the inverse buttons. The inverse buttons have those little negative ones on them. If you ask your calculator what is the inverse sine of and you put in a number that is in between -1 and 1. The only answers you can possibly get out of it are -π/2 to +π/2. It will only give you one answer. And that is really important for you to be clear on. What I'm hoping you'll see is why humans chose that to be the section we take. And understand that when it comes to math, there's certain points where humans have to make decisions, but then the logic has to flow once certain decisions are made. The decision of when we define inverse trig functions, what angles do we want to be able to come out as answers so that we still have a function? And it, oh my goodness. Online, can you hear that singing?
Yeah, I heard it. Must be loud for you guys.
Yeah. And it's
What was that?
I think they're practicing for a performance. What? Oh my gosh. Okay. I can't even do class with that much. I want the windows open to keep circulation. Okay, it stopped. Oh my gosh. Okay. All right. Anyway, what I just did was part D of using a pen to highlight the graph that was determined. Now, you are to write the interval that is highlighted in your graph that passes the horizontal line test. That interval is from -π/2 to +π/2. And it includes the endpoints. Now, the official notation of the inverse trig functions. For sine, you write the 3 letters, then in a superscript position, you're going to put the -1, but that is not a -1, it is an inverse symbol. Then you're going to go back to the line where you have the sin and write your variable x. Now, we sometimes write it as arc sine x to avoid the notation confusion. That notation confusion is the fact that when we write this, we mean the sine of x quantity squared. But when we write this, we do not mean the sine of x quantity to the power of -1. It's a very poor choice of notation that we have to deal with. So often you'll see it written as arcsine because of how confusing this notation is for people. I wish they would just flat out switch over and choose to use this notation, but textbooks, unfortunately, use both. Okay, okay, it's not just me being old, that's not pleasant. Okay. The music is unpleasant. All right. So I've got a lot written with the classwork answers, but this is primarily the thing you want to focus on. Okay, we're now going to go faster through the next ones. So here we go. Cosine. You should know the graph. It starts at its highest point, goes to midline, lowest point, midline, highest point, and that is the standard cycle that we use. But I want you to graph backward to a negative pi over 2. So if I graph backward, this will be the graph of my cosine. For each of these graphs, you are going to highlight just the 0 to pi over 2. We will always take the 0 to pi over 2 because that's coming out of our quadrant 1, which is coming directly from our right triangles. And if we're dealing with right triangles, we really want answers to be between 0 and pi over 2. So naturally, we want that to be part of the inverse angles that are used, that come out. However, we can take more than that and still have a function. So then the question of, if you continue forward and you highlight from pi over 2 to pi, will that pass the horizontal line test? And the answer is yes. Then if you go backward and you highlight to include negative pi over 2 to 0 with that highlight, will that entire highlight from negative pi over 2 to positive pi over 2 pass the horizontal line test? And the answer is no, it will not. But now I'm going to have to write no again. There we go. And then part D is to highlight what does pass. Oh my gosh. Oh, that is torture to the ears. I do not know what class is going through that kind of torture, but wow. In the past, I've found when it's the worst torturous kind of music, it's apparently freshman dance. And do any of you have some bad memories of that? No? Good memories of it? Oh, okay. I just found that it, for some reason, used some of the most hideous music. But that's my opinion. Okay. That was part D. Part E, we are going to write the interval that is highlighted in the graph that does pass the horizontal line test. And what I want you to see is that is 0 to pi. And then quickly, I'm going to say that we write inverse cosine in this manner, but we often use arc cosine x to avoid the notation confusion. Now, we have 4 more trig functions to go and 9 minutes to get it done in. Tangent x. You want to remember that tangent is sine divided by cosine. When cosine is equal to 0, we have vertical asymptotes. Cosine is 0 at pi over 2, pi over 2, 3 pi over 2. And then when sine is equal to 0, we have x-intercepts. And the fact that we understand that these create x-intercepts and vertical asymptotes takes us back to understanding rational functions when we were graphing those. So that would be at 0, at pi, at 2 pi. Tangent heads upward from asymptote to asymptote. Oh my God. How important is circulation in the classroom? Air circulation? Because I'm really close to saying close those windows. But then again, we only have 8 minutes. Okay, yeah, close the windows. I can't cope. I don't know about you, but I cannot cope with that. So if the 3 of you that are in the back, if you can just grab those handles and pull it in. You don't even need to close the handles. Just pull them in and that's all. I have to stand up on the desk to do it. Hold on. I can't cope with that. No, just shut the flaps. All right. That's what the flaps close. I'm pretty sure that is freshman PE. There was one day where I was giving a test while freshman PE was going on, dance, and I asked them to turn it off. It was horrible. If you can imagine trying to take a math test with, yeah. All right, we can hear it less now. So I just highlighted the 0 to pi over 2. That section definitely is used for the inverse. Then you have to figure out whether it's going to use continue from pi over 2 and go to pi, or if it's going to use go backward from 0 to negative pi over 2. It uses one or the other for every single one of these 6 trig functions. Now, if I go forward from 0 to pi over 2, I want you to see that due to the points I just highlighted extra, it does not pass the horizontal line test. I'm going to erase that.
Miss Blanchard, why would you highlight point or lines on the opposite side of the x-axis?
You mean on the opposite sides of the x-axis? What I'm doing is I'm highlighting either, for each one of these, I'm going to be highlighting from 0 to pi over 2. Let me actually go to the next blank graph just to emphasize. I'm always going to highlight whatever's occurring within that x interval. Then the test is highlight additionally to pi, wherever that happens to be with the graph, whether it's above or below the x-axis. Then we go backward and highlight whatever it is to negative pi over 2 and check that. And you'll see a bit more why when we get near the end. But every one of these, we're trying to figure out whether we want to use 0 to pi or negative pi over 2 to positive pi over 2. And the point that I want to make here is why the choices were made to either extend it to pi or to extend it backward to negative pi over 2. Because for each one of these, we are not going to get both of these being yes or both of them being no. And so there's a forcefulness to which of those 2 cycles it uses for its backward function. People end up memorizing them, but I think it's really, really valuable if you understand why they were chosen. Then when you do have to memorize them, it'll make more sense. So because 0 and pi have the same y coordinate, I can't use 0 to pi. But if I go backward and I highlight where the graph exists from 0 back to negative pi over 2, I can see that this section does pass the horizontal line test. And that is why it is the official interval that we use. So that interval is negative pi over 2 to pi over 2, but because they're asymptotes at those endpoints, technically, we don't include them. But what's really important is that you know whether you're dealing with negative pi over 2 to pi over 2, or if you're dealing with 0 to pi. And then real quick, for tangent, we write inverse tangent that way, or we write it arctangent x to avoid that notation confusion. Okay, 3 graphs to go in 1 minute. Well, cotangent. Cotangent is cosine divided by sine. So I have asymptotes at 0, pi, 2 pi. I go through the x-axis at pi over 2, 3 pi over 2, and negative pi over 2. Cotangent goes only downward between asymptotes. And then if I highlight 0 to pi over 2, the question is, if I continue to highlight to pi, does it pass the horizontal line test? And the answer is yes. If I go backward, the answer is going to be no, because at negative pi over 2 and at pi over 2, we have y values that are both 0, and it doesn't pass the horizontal line test, which means that this is 0 to pi, and we write it inverse cotangent or arc cotangent of x. And then I'm going to tomorrow quickly do those last 2 graphs. And I am out of time. And oh my gosh, now